Gait is the translatory progression of the body as a whole. It is produced by coordinated movements of body segments. There are two phases of the gait cycle, known as the stance phase and the swing phase. The main goals of gait are to support the head, arms, and trunk, prevent collapse of the lower extremity, maintain postural balance, and control foot trajectory to clear the ground. In addition, another goal is to generate mechanical energy to keep forward velocity and absorb mechanical energy for shock absorption and stability to decrease forward velocity. The term gait cycle refers to two successive events of the same lower extremity from initial contact to initial contact. The stance phase accounts for 60% of the gait cycle and occurs when some part of the foot is in contact with the floor. The other 40% of the gait cycle is known as the swing phase and occurs when the foot is not in contact with the floor. Double limb support during the gait cycle occurs when one limb makes initial contact and the other limb is leaving the floor. There are two periods of double limb support during the gait cycle, each lasting for about 11%, for a total of 22% of the cycle. The first period of double limb support occurs during the initial contact or heel strike phase and loading response or foot flat phase. The second period occurs during the pre-swing or toe off phase. The body is in single limb support for almost 80% of the cycle. The 5 events that occur during the stance phase of gait are heel strike, foot flat, mid stance, heel off, and toe off. For the purpose of this video, we will be analyzing the subject's right leg for reference. We will be breaking down each phase of the gait cycle, joint by joint, beginning with the ankle, followed by the knee and the hip. Heel strike, also known as initial contact, occurs the instant the heel of the leading lower extremity makes contact with the ground. The main goal of this event is weight acceptance and positioning of the foot for loading response. The line of gravity falls posterior to the ankle, so there is an external plantar flexion moment and an internal dorsiflexion moment to counter it. The muscles active here are the tibialis anterior and the extensor digitorum longus. In heel strike, the line of gravity falls anterior to the knee, so there is an external extensor moment. Internally, the quadriceps contract to prepare for the loading response and the hamstrings counteract the external extension moment. This extension torque stabilizes the knee joint. At the hip and pelvis, the line of gravity falls anterior during heel strike, and there is a rapid external flexion moment. Internally, the hip extensors, such as the gluteus maximus, adductor magnus, and hamstrings, are active to stabilize the thigh during loading response. This helps the hip and pelvis move forward. The second event of the stance phase is known as foot flat or loading response, and occurs when the weight is transferred to the outstretched limb and the entire foot is flat on the ground. The main goal for this stage is also weight acceptance. The foot will be pronated in order to adapt to the surface the individual is walking on. In foot flat, the line of gravity remains posterior to the ankle, so there is still an external plantar flexion moment which forces the foot to contact the surface. Internally, there is a peak eccentric contraction of the tibialis anterior, and the gastrocnemius is activated to control the forward movement of the tibia. The pretibial muscles serve to pull the tibia forward during foot flat, and this forward momentum initiates knee flexion. At the knee during foot flat, the line of gravity moves posterior to the joint, so there is an external flexor moment. Internally, there is a peak eccentric contraction of the quadriceps, which helps with shock absorption and stability while the limb progresses forward. The line of gravity falls anterior to the hip and pelvis during foot flat, so there is an external flexion moment countered by an internal extensor moment, as well as an adductor moment countered by an abductor moment. Internally, the gluteus maximus, adductor magnus, and hamstrings counteract the external flexor moment, and the TFL and gluteal muscles stabilize the pelvis along the frontal plane. These muscles help with stability and shock absorption of the hip and pelvis. The third event of the stance phase is known as mid-stance, and it's the point where the weight of the body is directly over the supporting extremity and single limb support. During mid-stance, the line of gravity moves anterior to the ankle, so there is now an external dorsiflexion moment countered by an internal plantar flexion moment. The soleus and gastrocnemius serve to control the forward progression of the tibia while the body continues to move forward. At the knee, the line of gravity is anterior, so there is an external extensor moment and an internal flexor moment. As this moment increases, quadricep activity decreases. Internally, the calf muscles are also active to prevent the tibia from allowing the femur to move too fast, making the knee more stable. At the hip and pelvis, the line of gravity is posterior, creating an external extensor moment countered by an internal flexor moment. There is also an external adductor moment countered by an internal abductor moment. Internally, the abductor muscles of the hip are highly active and help with pelvis stability in the frontal plane. The fourth event of the stance phase is heel off, also known as terminal stance, in which the heel of the lower extremity leaves the ground and the body moves ahead of the limb and weight is transferred to the contralateral limb. During heel off, the line of gravity is anterior to the ankle, so there is an external dorsiflexion moment countered by an internal plantar flexion moment. In addition, there is a toe flexion moment. Internally, the calf muscles are at their peak, preventing forward collapse of the tibia, while also allowing the heel to rise from the surface. During this phase, the line of gravity is anterior to the knee, so there is an external extension moment countered by an internal flexor moment. Because of the large external extension moment, the quadriceps are not active. The calf muscles continue to control the tibia, creating stability in the knee joint, but still allowing for forward progression. At the hip and pelvis during heel off, the line of gravity is posterior, creating an external extensor moment and an internal flexor moment. At this phase, the adductor moment starts to decrease. Internally, the anterior fibers of the TFL are active. The rotation of the pelvis allows for smooth advancement of the body as it passes the foot. The fifth and final event of the stance phase is toe off, also known as pre-swing, where the toe of the foot also leaves the ground and there is rapid unloading as weight transfers to the contralateral limb. This is also the second instance of double limb support. The line of gravity is still anterior to the ankle and toe off, but this external dorsiflexion moment decreases. Internally, there is also a decrease in the calf muscle activity, but the limited activity helps move the ankle into plantar flexion while also assisting with knee flexion. At this phase, the forefoot is still on the floor to assist in balance. During toe off, the line of gravity falls posterior to the knee, so there is an external flexion moment countered by an internal extension moment done by the quadriceps. In this phase, there is initial flexion of the knee to enter the early swing phase of gait so the limb can clear the surface. At the hip and pelvis, the line of gravity is still posterior, but this external extensor moment decreases as the limb is unloaded. Internally, the adductor longus brings the femur into a flexed position with the help of the rectus femoris. This functions to begin advancement of the limb. The swing phase of gait accounts for 40% of the gait cycle, and there are 3 events. The first event is early or initial swing, the second event is mid-swing, and the third event is late or terminal swing. The main goals of the swing phase are to unload the limb, accelerate progression forward, foot clearance, and completing limb advancement so that the limb is moved from behind to in front to prepare for the next stance phase. The first subphase of the swing phase is known as early or initial swing, and it accounts for 60 to 75% of the total swing phase. It's the event in which one toe leaves the ground until mid-swing, or the point at which the swinging lower extremity is directly under the body. It's also known as the acceleration phase. During early swing, the line of gravity is posterior to the ankle, so there is a slight external plantar flexion moment. Internally, the pretibial muscles are active to initiate dorsiflexion, and there is a peak in the activity of the extensor hallucis longus and extensor digitorum longus. Dorsiflexion allows the foot to begin to clear the ground, but the ankle is still in a plantar flexion position at this phase. The line of gravity is posterior to the knee, so there is an external flexion moment. Internally, there is peak activity of the biceps femoris, sartorius, and gracilis. At this phase, the foot starts to clear the floor as the thigh advances forward. At the beginning of early swing, the line of gravity is posterior to the hip, so there is an external extension moment, but by the end of this phase, this torque is 0. Internally, there is peak activity of the iliacus, gracilis, and sartorius, and the adductor longus is also active. The hip allows for continued limb advancement. The second phase of the swing phase is known as mid-swing, and it accounts for 75 to 85%. It is the phase in which the lower extremity passes directly beneath the body, and it's the transition point between the acceleration and deceleration of the swinging lower extremity. During mid-swing, the line of gravity is still posterior to the ankle and there is an external plantar flexion moment. Internally, the pretibial muscles are active, allowing the foot to clear the ground. At the knee, the line of gravity is anterior. Therefore, there is an external extension moment and an internal flexion moment. Knee extension at this phase is accomplished with the help of gravity and momentum, but is controlled internally by the hamstrings. Knee extension is important to accomplish sufficient step length. As the tibia advances, the line of gravity moves anterior to the hip and pelvis, creating an increasing external flexor moment. Internally, the hamstrings are active to slow thigh advancement. The final part of the swing phase is known as late or terminal swing, and it accounts for 85 to 100%. It is the event in which the limb is decelerating in preparation for the next heel strike. At the ankle, the line of gravity starts posterior, so there is a small external plantar flexion moment, but this moment is reduced to 0. Internally, the pretibial muscles are active to prepare the limb for heel strike, the first phase of gait. During late swing, the line of gravity is anterior to the knee due to the forward advancement of the tibia, creating an external extension moment. Internally, the quadriceps concentrically contract to make sure the limb is extended and the hamstrings have a peak activity to decelerate the limb as it reaches forward in preparation for heel strike. The line of gravity is posterior to the hip and pelvis during late swing, so there is an external extensor moment. Internally, the anterior fibers of the TFL are active as the body advances past the foot smoothly with the assistance of the pelvis. The hamstrings and gluteus maximus eccentrically contract to control the deceleration of late swing. The number of steps a person takes per minute is known as cadence, and the normal cadence of a person is 80 to 120 steps per minute. When somebody increases their cadence, they will reach a point where time spent in double limb support decreases and becomes non-existent, and the individual will then transfer from walking to running. This occurs when the cadence is greater than 180 steps per minute, which is approximately 4 to 4.5 miles an hour.